Welcome to the demonstration of PolariQon's ability to run QUBO optimization. QUBO is an acronym for Quadratic Unconstrained Binary Optimization. QUBO can be used for drug discovery, logistics, scheduling, AI training, cryptography, and more. QUBO is hard to run because first of all qubit connectivity is required, meaning all qubits have to be entangled with all the other qubits. Every qubit must interact with every other qubit, which is what I mean by saying all of them need to be entangled. Any heat, any positive heat will destroy quantum states instantly. That's why there's a need to cool them at a very low temperature. And gate errors at any gate will compound with every step. There's another company that runs QUBO. It's D-Wave, but they can only give approximate solutions because they're not gate-based, they're annealing based. With all-to-all entanglement, you have the ability to have 1.1 quadrillion combinations with just 50 qubits or just 50 variables. This is a comparison of PolariQon's capabilities with IBM, Google, IonQ, and D-Wave based on publicly available data. PolariQon runs at room temperature, is gate-based. It runs BV Bernstein Vazirani cores, and it runs QUBO natively. If you look at IBM, Google, IonQ, and D-Wave, they all have limitations. PolariQon, on the other hand, has no limitation. So let's go to the demo. As you can see, we have by default Q0 to Q10 assigned to different stocks from APL to XOM, and these numbers on the right are the return that these companies have given over the last 7 years. What we will do is we will clean this up and load our own program. So let's just do this first. So load our own CSV, and let's do this. Okay, we loaded it. I can see the numbers have changed, and the program tells me that the new file has been loaded. You can see the P number and all these numbers have changed. Now that we have it, we're ready to connect the computer. We could have connected the computer even earlier, but let's connect it now. Okay, now the computer is running, the quantum computer is running. Okay, this is just collecting data. Let's do this first. Before we do anything else, let's look at the 11 by 11 matrix that that's created with this. You can see the diagonal negative numbers. The diagonal negative numbers basically is the more negative it is, the less the energy, the higher the reward. So you can see the combinations, AAPL to AAPL gets the best reward here. With other companies, it varies. So essentially, it gives you the reward, and this is the expected return on the right hand side. So with this, let's go to actually running the program. Before we run the program, let's do the baseline. Baseline is the same as initialization in our case. Is our qubits are initialized this way. So we will run the initialization for some time, and after the initialization, or which means capturing the baseline, we will run the program. So I think we're ready to run the program now. Let's do this. Let's run the program. When we run the program, you can see that these waves, the oscilloscope pattern is going to change, and then we will get an output. So you can see the pattern is changed, and we are going to get the output. So this is the output. You can look at it carefully. What it has done is it has given us hardware QUBO score of x transpose over x to be minus 0.35. Again, the lower it is, the better. The lower the number, the better it is. This is the minimum value it is optimized to. If you want to understand this, this is the raw answer that came out of the hardware. Each bit 0 or 1 maps to one stalk in order, and 1 obviously means keep it, and 0 means skip it. So you can see APL is skip, and Microsoft is on, and that sort of thing. The hardware physically collapsed into this state. It is not a calculation, it is a measurement. The score is, as you can see, it was minus 0.35. This is the QUBO score for the bit string against the Q matrix you saw earlier. More negative means better. The hardware found a combination where rewards, which means negative diagonal terms, outweighed the correlation penalties, which is positive off diagonal terms, by a net of minus 0.352. Okay, and you can understand the meaning. If you one stock, combination of one stock versus with another, it's a negative, so it's skipped. That means the combination doesn't work very well. So based on all this, it has selected 3 stocks: Microsoft, Nvidia, and Tesla. So this is what the hardware picks. This is not a simulation, this is actual calculation. If you have any questions regarding this, PolariQon will be happy to answer the questions. For now, thank you very much for watching.